Good day, Damians! For this sixth video, we will be talking about operations on functions. We have two goals for this week's lesson. These are, at the end of the lesson, you are expected to add, subtract, and multiply functions. And secondly, you are going to solve problems involving operations and functions in real life. Enjoy learning!
To start our lesson, let's have first the definition of the sum, difference, and product of functions. Let f and g be any two functions. The sum, f plus g, difference, f minus g, and product, f, g, are functions whose domains, or the set of all real numbers, come to the domain of f and g and defined as follows. For the sum, we have f plus g of x is equal to f of x plus g of x. For the difference, f minus g of x is equal to f of x minus g of x. For number 3, the product, f g of x is equal to f of x times g of x. In adding functions, you have to examine first the given functions. Second, arrange the terms, base the order in terms of the degree. You have to take note that in arranging, make sure to copy the sign of the term. Third, you have to simplify. In simplifying, look for like terms. In case that like terms exist, just add the numerical coefficient of all like terms and copy its corresponding variable and exponent. Let's try this problem. Find the sum. Given the function f of x is equal to 4x plus 3 and the function g of x is equal to 3x minus 2, find f plus g of x, and secondly, find f plus g of negative 3.
First example, we are tasked to solve for the sum of f of x and g of x. So the given f of x is 4x plus 3 and the given g of x is 3x minus 2. So I have it written here. So we have 4x plus 3, and then we are going to multiply or distribute this positive sign into the second function g of x, which is 3x minus 2. So positive times 3x is positive 3x, and positive times negative 2 is negative 2. Now we are going to arrange the terms in descending order. So we are going to base the arrangement into the degree of our terms. So here we have 4x and 3x. They are having the degree of 1. So we have 4x plus 3x, and then the constant plus 3 and negative 2. So plus 3 and minus 2. So here we are going now to add like terms. So obviously we have here like terms 4x and 3x. Why are they like terms? Because they have the same variable and their variable have the same exponent. So they have the exponent 1. And also we have 1 here. So 4x plus 3x is 7x. Why 7x? Because we just have added the numerical coefficients 4 and 3 that resulted to 7, and then we just copied the variable x. Now we are going to deal with the constants positive 3 and negative 2. So adding the 2, this will result to positive 1. So the sum of the functions f of x, which is 4x plus 3, and g of x, which is 3x minus 2, is 7x plus 1. For the second example, we are going to add the sum of f of negative 3 and g of negative 3. So to do that, we have f of negative 3 plus g of negative 3. So we are incorporating here evaluating functions with operations on functions. So to solve for this, we have to find first f of negative 3 and g of negative 3. So we have f of negative 3 is equal to, the given is 4x plus 3. So this will become 4 times negative 3 plus 3.
And then we have 4 times negative 3, that's negative 12, and then plus 3. So negative 12 plus 3, that is negative 9. So that is for f of negative 3.
How about g of negative 3? So for g of negative 3, we have the given function is 3x minus 2. So this will become 3 times negative 3 minus 2.
So we have 3 times negative 3, that's negative 9, minus 2, and then we have negative 11.
Now we are going to substitute these answers into our equation. So f of negative 3 is negative 9, plus the g of negative 3, which is negative 11. Okay, so adding the two, negative 9 and negative 11, we have the answer, which is negative 20. That's it.
In subtracting functions, you have to examine first the given functions. Secondly, distribute the negative sign to the minuend or the second function. Third, arrange the terms in descending order. Again, you have to base the order in terms of the degree. And lastly, you have to simplify. Let's try this. Find the difference given the function f of x is equal to 2x squared minus 3x minus 2 and the function g of x is equal to 4x squared plus 5x plus 3. We have to find first f minus g of x, and second we have f minus g of negative 1.
For the third example, we are going to solve for the difference of f of x and g of x. So f of x is equal to 2x squared minus 3x minus 2 minus the given g of x, which is 4x squared plus 5x plus 3. Okay, so it's very important that you have to enclose the functions first in a parenthesis. It's because there will be changes in the sign of our second function because the second function will be multiplied to a negative. So here we have to copy the first function, 2x squared minus 3x minus 2, and then we are going now to distribute the negative sign into the second function. So this will become negative times 4x squared is negative 4x squared, negative times 5x is negative 5x, and negative times 3 is negative 3. So that is now the resulting equation. We have now to arrange this equation in terms of their degree. So from the highest degree to the lowest. So here, the highest degree is 2 because we have exponent 2 here. So we have the terms 2x squared and negative 4x squared. So we have 2x squared and negative 4x squared. So it's very important that you are rearranging terms. You have to carry with the term its sign. So here we have positive 2x squared is still positive 2x squared. Negative 4x squared is still negative 4x squared. Now next to the degree 2 is degree 1. So we have terms negative 3x and negative 5x. So we have negative 3x and negative 5x. And then lastly, we have the constants negative 2 and negative 3. So we have minus 2 and minus 3. So that is now the resulting equation that we have rearranged. So to help you check if you have rearranged it the correct way, you are going to count the original equation or the terms in the original equation. So we have 1, 2, 3, 4, 5, 6. Now you are expected to still have 6 terms in the resulting rearranged equation. So we have here 1, 2, 3, 4, 5, 6. So after checking your equation, we can now proceed with combining like terms. So like terms, here we have 2x squared and negative 4x squared. So 2 minus 4, that is negative 2, and then copy x squared. We also have here negative 3x and negative 5x. So negative 3 and negative 5, that is negative 8, and then we have to copy x. And then we have the constants negative 2 and negative 3, that is negative 5. So the difference of the functions f of x and g of x is negative 2x squared minus 8x minus 5. For the fourth example, we are going to find the difference of f of negative 1 and g of negative 1. So here we are again incorporating evaluating functions with operations on functions. So we have to solve first for f of negative 1 and then g of negative 1 before we are going to subtract their answers. So f of x is equal to 2x squared minus 3x plus 2. Now finding f of negative 1, we have to substitute negative 1 into the value of x.
So we have 2 times negative 1 squared minus 3 times the x, which is now negative 1, plus 2. Now applying the PEMDAS rule, we have negative 1 squared, that's 1 times 2. So we have 2. We have negative 1 times negative 3, that's positive 3, and then plus 2. So we have 2 plus 3, that's 5, plus 2, that's positive 7.
Now how about g of negative 1? So the given g of x is equal to 4x squared plus 5x plus 3.
Now evaluating g of negative 1, we have 4 times the x, which is now negative 1 squared, plus 5 times the x, which is now negative 1 plus 3. So we have here 4 times negative 1 squared. So negative 1 squared is positive 1 times 4, that's 4. And then we have negative 1 times positive 5, that's negative 5, and then positive 3. So 4 minus 5, that is negative 1. Negative 1 plus 3, that is 2, positive 2. Okay.
So the resulting f of negative 1 is 7 minus the resulting g of negative 1 is 2. So 7 minus 2, that is 5. So the difference of f of negative 1 and g of negative 1 is 5.
Now let's have multiplication of functions. In multiplying functions, examine first the given functions. Second, multiply the functions and you have to apply here the laws of exponents. In multiplying, make sure to multiply each term of the other function to all of the terms of the second function. Third, you have to rearrange the terms in descending order. You have to base the order in terms of the degree. And lastly, you have to simplify. Try this. Find the product given the function f of x is equal to x squared minus 5x plus 2 and the function g of x is equal to 3x plus 1. Find f times
For
g.
example number 5, we are now tasked to solve for the product of the functions f of x and g of x. So the given f of x is x squared minus 5x plus 2 and the given g of x is 3x plus 1. So there are multiple ways in solving or in multiplying these functions, but what I'll be doing now is I will be multiplying each of the terms of the first function into our second function. So it goes like this. We have the first term, x squared, multiplied to 3x plus 1. The second term is negative 5x multiplied to 3x plus 1. And the last term is positive 2 multiplied to 3x plus 1. So now I will multiply x squared into 3x plus 1. So this is x squared times 3x. That's 3x cubed. Now why 3x cubed? Because here I have multiplied its coefficient. The coefficient of x squared is 1. So 1 times 3 is 3. Now, in its variable, we have x squared and x. So in multiplying x squared and x, you have to copy the variable x and then just add their exponent. So we have 2 here and then we have 1 for here. So 2 plus 1, that's 3. Now, we have x squared multiplied to positive 1. So of course, that is positive x squared. Now, that is for the first term of our first function, x squared minus 5x plus 2, which is x squared. Now let's have the second term, negative 5x multiplied to 3x plus 1, which is this one. So we have negative 5x times 3x, that is negative 15x squared. Why negative 15? Because we have negative 5 times positive 3, that's negative 15. We have x times x, that's x, and then these have an exponent of 1. So 1 plus 1, that is 2. Now, we have negative 5x multiplied to positive 1, and that is negative 5x. And lastly, we have the term 2. So 2 times 3x plus 1. So positive 2 times 3x, that's positive 6x. And then positive 2 times 1, that's positive 2. And for now, we are going to arrange our equation. So luckily, the equation is already in its descending order because we have the degree or the exponent 3 here, and then 2, 2, and then 1, 1. And then the constant 2. So here we are just going to add like terms. So 3x cubed, we have no other term which has x cubed in it. So we just have to copy the x cubed. Now we have positive x squared and negative 15x squared. So we can combine these terms because they have the same variable and their variable have the same exponent too. So this has a numerical coefficient of 1. So we have positive 1 here, and then we have negative 15 here. So positive 1 and negative 15, that's negative 14, and then copy x squared. And we also have negative 5x and positive 6x. So negative 5 and positive 6, that will result to positive 1x. And then we have the constant 2. Okay, so now we will rewrite this equation because we can still simplify this 1x. So this will become now 3x cubed minus 14x squared. Instead of 1x, just have x and then plus 2.
Next, find the product given the function f of x is equal to square root of 3 plus x and the function g of x is equal to the square root of 3 minus x. Find f times g of x.
We are going to solve for the product of f of x and g of x. So given the f of x, which is square root of 3 plus x, and the g of x, which is square root of 3 minus x. So multiplying the two functions, we will have, or we will distribute the terms of the first function and then multiply it to the terms of our second function. So we have square root of 3 for the first function multiplied to the second function, square root of 3 minus x. And then the second term, which is plus x, multiplied to this second function, square root of 3 minus x. Okay, so square root of 3 times square root of 3, that is positive 3. So the underlying principle for that is this. So square root of 3 times square root of 3. So the base here is 3 and its exponent, or writing this in rational exponent, that is 1/2 times 3 raised to 1/2. So these are just equivalent. So since we have the same base here, 3, we will just add their exponent 1/2 plus 1/2. So that is 1. So 3 raised to 1, that is 3. So now square root of 3 times negative x. So that is negative x square root of 3. So that is the answer for the first term multiplied to our second function, square root of 3 minus x. Now, going to our second term, positive x multiplied to our second function, square root of 3 minus x. So multiplying, we have positive x times square root of 3, that is positive x square root of 3. And then positive x times negative x, that is negative x squared. Okay, so we will arrange our terms from descending order. So the highest degree here is 2, or the highest exponent is 2. So we have negative x squared, though don't forget to copy the sign of the term x squared, which is negative. So negative x squared, and then next is minus x square root of 3, and then plus x square root of 3, and of course the constant 3. So notice that we have negative x square root of 3 here and positive x square root of 3. So combining these two terms, we will have 0. Why? Because we have here negative x square root of 3 and a positive x square root of 3. So this will be 0. Now for the final answer, we have negative x squared and then the constant positive 3. So the answer in multiplying the function f of x and g of x, whose f of x is square root of 3 plus x and g of x is square root of 3 minus x, is equal to negative x squared plus 3. So for problem solving number 1, we are given a rectangular pen whose length is 2 more than twice the width, which is x. And then we are tasked to find its perimeter. So to help us solve, for the perimeter, we have to do an illustration of the problem first. So we have here a rectangular pen. The shorter side is the width x. So we have here x, and the longer side is the length, which is 2 more than twice the width. So this is obviously the length. And this is also the length. So what is now the measurement of our length? It says that it is 2 more than twice the width. So if we have x for the width, we have 2 more than twice of the width. So that is now the measurement for our length. So this is also 2 more than the twice of the width x. To solve for the perimeter of our rectangle, we have to add all of the sides of our rectangle. We have the formula 2L plus 2W. Why 2L plus 2W? It's because we have here 2 lengths and 2 widths. So we are going to add all of its sides. So we have now to substitute the length, which is 2 plus 2x, and the width, which is x, into our formula. So here, this is our length and this is our width. So now we are going to distribute 2 to our L, which is 2 plus 2x. So we have 2 times 2, that is positive 4, and then 2 times 2x, that's positive 4x. And then of course we have plus 2 times x, that is 2x. Now let's rearrange first the terms in accordance to its degree. So we have the highest here is degree of 1. So we have 4x and 2x. So positive 4x plus 2x. And then last is the constant 4. Okay, so we have now 4x plus 2x, which is 6x plus the constant 4. So the perimeter of our rectangle, whose width is x and whose length is 2 plus 2x, is equal to 6x plus 4 units. Now for the follow-up question, letter B, we are given the width, which is 5 meters, and then we are going to solve for the perimeter of the rectangular pen.
So we have the same rectangular pen whose width is x and whose length is 2 plus 2x.
So the width now will become 5 and the length now will become 2 plus 2 times 5. So this will become 2 plus 2 times 5, that is 10, and the length is 12. So of course, don't forget the unit of measurement, meters. So now solving for the perimeter, still we are going to use the formula 2 length plus 2 width. So we have 2 times the length, which is 12 meters, plus 2 times the width, which is 5 meters. So we have 2 times 12, that is 24, plus 2 times 5, that is 10. So 24 plus 10, that is 34. Of course, don't forget the unit of measurement, meters. So the perimeter of a rectangular pen, whose width is 5 meters and whose length is 12 meters, is 34 meters.
Now for problem solving number 2, still we are having the same rectangular pen whose length is 2 more than twice the width x. But here we are going to solve for the area. So here we have the same illustration. This is the rectangular pen whose width is x and whose length is 2 plus 2x.
Now in solving for the area of this rectangular pen, we have the formula length times width, or that is L times W.
So our length here is 2 plus 2x. So 2 plus 2x, and then the width is x.
Okay, so multiplying, we have the first term 2 multiplied to the second function x, plus the second term 2x multiplied to the function x. So we have 2 times x, that is 2x, and then we have 2x times x, that is 2x squared. Units squared. So this is now the area.
For follow-up question letter B in our problem solving number 2, we are going to find the area of the same rectangular pen, but this time the width is 7 feet. So if our width is 7 feet, and this is the x, and our length, which is 2 plus 2x, this will now become 2 plus 2x, which is now 7 feet. So this will become 2 plus 2 times 7, that is 14, and 2 plus 14 is 16. So this is now 16 feet. Our width is 7 feet, and our length is 16 feet.
So solving for the area, we have length times the width, and this is equal to the length is 16 feet, and the width is 7 feet. So 16 times 7, that is 112 feet squared. So the area of our rectangular pen, whose now width is 7 feet and whose length is 16 feet, is equal to 112 feet squared.
So that's it. That concludes our lesson for this week. I hope you are now able to add, subtract, and multiply functions and solve problems involving operations and functions in real life. This is your teacher, Miss Mary Christine Gamuzo Antalan, saying thank you and keep safe, Damians.